All right, let's dive right in. For centuries, we've been trying to understand the mind with philosophy, psychology, neuroscience, you name it. But what if we've been looking in all the usual places and the real key, the deepest insight, came from somewhere else entirely? What if the secret to unlocking the brain was actually math? I mean, what if I told you that there's a single mathematical principle that could explain how we see, how we learn, how we act, and maybe even consciousness itself? Now, I know that sounds absolutely grandiose, but it might just be true. In this explainer, we are going to unpack the incredibly elegant and powerful mathematics that could be the fundamental operating system for the mind. Okay, so first things first, what is the brain's number one job? You might say thinking, or feeling, or making my arms move. And yeah, those are all on the list. But underneath all of that, there is a much, much bigger challenge it has to solve first. Think about it. Your brain is locked inside a dark, silent box, your skull. That's it. All it ever gets are these noisy, kind of fuzzy electrical signals coming in from your senses. The light hitting your eyes, the vibrations hitting your eardrums. None of that is the world. It's just clues. So every single thing you perceive, every face, every sound, every feeling, is just your brain's best guess about what's really out there. Its entire existence is about making inferences and trying to make them as good as possible. So if the brain is basically a high-stakes guessing machine, how does it get any better? How does it learn from experience? Well, it turns out there is a mathematically correct way to update what you believe when you see new evidence. It's really just a simple three-step dance. First, you start with a prior. That's just a fancy word for what you already believe or expect to be true. Then, step 2, you get some new evidence, something you see or hear or feel. And finally, step 3, you combine that prior belief with the new evidence to form a posterior, your new, updated, and hopefully more accurate belief. That's it. That's the cycle of learning. And that whole logical process, it's captured perfectly in one beautiful little equation, Bayes' theorem. Now, your new posterior belief is basically your old prior belief multiplied by something called the likelihood. The likelihood is just a score for how well your belief predicted the new evidence. So if your prior belief is, it might be raining, and then you hear a pitter-patter on the window, the likelihood of that sound, given that it's raining, is super high. This little formula is basically the engine of all rational learning. Okay, cool. So the brain just has to run Bayes' theorem on everything. Problem solved, right? We can all go home. Well, not so fast. There is a massive, catastrophic flaw hiding inside this perfectly logical little equation. The problem is that little evidence term on the bottom. To calculate that number perfectly, your brain would have to think of every single possible explanation for what it's sensing. Everything from it's raining, to a squirrel is throwing tiny pebbles at my window, to I'm in a simulation, and add them all up. Not just the likely causes, but literally all of them. And the number of possible causes for anything in the real world is, well, it's just astronomical. I mean, for any reasonably complex problem, like, say, recognizing a friend's face in a crowd, the number of calculations you'd need to do this perfectly is larger than the number of atoms in the entire known universe. No joke. So let's just be crystal clear about this. Perfect, exact Bayesian inference is computationally impossible. The brain, with its squishy hardware and limited energy budget, simply cannot do it. It's a non-starter, which feels like we've just hit a massive dead end. But the brain has an incredibly clever workaround, a truly elegant solution. It doesn't even try to find the perfect, exact answer. Instead, it does something way smarter. It finds a really, really good approximation. So instead of trying to solve that impossible calculation to find the one true belief, the brain just changes the question. It asks, okay, what's a simpler belief that I can actually handle that gets me as close as possible to that impossible truth? It cleverly turns an impossible math problem into a solvable optimization problem. And this, right here, is where we find our one equation to rule them all. The thing that guides the search for the best guess is called variational free energy. Now, don't worry about the crazy-looking formula. All you need to know is what it does. Think of free energy as a score for how bad your current guess is. The brain's one and only goal is to tweak its beliefs to make that score as low as it can possibly go. And by doing that, it automatically finds the best possible guess. Oh, and one quick side note, this is free energy from information theory, not the same stuff you might remember from physics or chemistry class, even though they are mathematically related. So what is this free energy thing, really? when the brain is trying to push that number down, what is it actually doing? Well, it turns out free energy is made of two fundamental, competing forces that are constantly shaping everything we perceive and believe. At the end of the day, free energy is basically just complexity plus inaccuracy. Inaccuracy is pretty straightforward. It's a penalty for being wrong, for having a belief that doesn't explain what your senses are telling you. Complexity is a penalty for changing your mind too much, for creating a new belief that's wildly different from your old one. So minimizing free energy is this constant tug of war. Be as accurate as you can, but also be as simple as you can. Okay, stick with me, because this is where the idea just explodes in scope. Another way to think about minimizing free energy is minimizing surprise. And this is super important. We're not talking about emotional surprise, like at a birthday party. This is a technical, mathematical kind of surprise. It's just the mismatch between what your brain expects to happen and what it actually senses. And it turns out that trying to keep this surprise low unifies things we always thought of as completely separate. You see, there are two, and only two, ways to reduce the surprise, to lower your free energy score. The first way, you can change your beliefs to match the world. You hear that pitter-patter, you feel a drop of water, and you update your internal model to, it's raining. We call that perception. But there's another way. You can actually change the world to match your beliefs. If you believe your hand is holding a warm cup of coffee, you can act on the world by moving your arm and fingers until that prediction becomes true. We call that action. Perception and action, seeing and doing, are just two sides of the exact same coin, the fundamental drive to minimize surprise. And that is the really profound takeaway here. This whole mathematical framework, the free energy principle, it isn't just a clever description or a neat metaphor for what the brain does. It's a very serious candidate for what a mind is. It might be the fundamental physics of how intelligence works, how we perceive, how we learn, and how we act. So we have this unbelievably powerful guiding principle, this single objective function for all of cognition. But a principle needs a structure to work on. It needs an architecture, a way to actually represent all that knowledge about the world. So what kind of machine could possibly perform this cosmic calculation? Well, that's where things get even more interesting, because the answer might lie in a structure as simple and as powerful as a graph.